Good afternoon, and thank you all for joining us here today. This is our second session in our AI webinar series, and it's great to have you all back. In our first webinar, we focused on building a successful AI roadmap, identifying the right opportunities to ensure your return on investment, alignment with business challenges and getting your data in the right place, and taking a structured approach to adoption rather than just experimenting for the sake of it. We've all been there. What we often see is that even with a strong roadmap in place, the real challenges starts when the rubber hits the road and beyond that initial pilot and you need to scale it out for production. My name is Darrell King and I am the CEO of PolarSeven. We are a consulting and managed services organization deploying solution for businesses on the AWS platform since 2013. Some quick housekeeping. I'm guessing you've all been on a Zoom at some stage before, but if you have any questions, you can pop them in the Q&A and we will run through them at the end. If we don't get time, we'll obviously follow up with you. Presenting with us today, we have back with us again, we have our PolarSeven BDM Jackson, who will kick us off by walking through some of the common pitfalls we see. And then we'll hear from Robin, CEO of Xtramile Solutions, who will share a real-world example from the healthcare space, including their experience in designing and deploying an AI assistant working directly with patient data. Let's get into it. Over to you, Jackson.
Thanks, Darrell. And thanks everyone for joining. So what I want to focus on today is something that we see quite consistently when organizations start moving beyond the experimentation with AI. There's usually a lot of early momentum. A team identifies a use case, builds a proof of concept, and the results are looking promising. Everyone's excited. But when that same solution is introduced into a real world environment with real users, real data, and real constraints, that's often where things tend to change. And this isn't a niche issue that we see in the industry. We've seen multiple cases across enterprise businesses that have real ramifications or have had to pull out of production altogether. A great example of this is a pretty well-known case involving a major airline that occurred 2 years ago. They had a chatbot that gave a customer incorrect refund advice, and when the customer challenged it, the airline argued the chatbot wasn't a real representative of the airline. However, the court didn't agree, and they ruled that the company is responsible for what its AI says. So very quickly, the conversation shifts. It's no longer just, can we build something with AI? It becomes, can we trust it, control it, and scale it without introducing risk? And when you take a step back, it really comes down to these four things: trust, control, scalability, and complexity. If I had to summarize the challenge simply, most proof of concepts fail because they're designed to prove something works, not to survive in the real world. So first I wanted to dive into why proof of concepts often break down. When we look at different use cases, there's a couple of patterns that show up quite consistently. One of the first places that breaks is trust. And the reason this really matters is because the moment trust drops, usage drops with it. It doesn't matter how powerful the system is or how successful it is. If people are second guessing the output, they end up stop relying on it altogether. And a good example of this, we explored a use case in the education space, generating maths questions and their multiple choice answers for a bunch of different education levels. At first glance, it looks strong. We could generate large volumes of questions across different grades, and it seemed like it was something that we could scale. But as we tested it more thoroughly, reviewing a large sample of outputs and looked how it would behave in practice, what we found wasn't just occasional errors. It was that the model would sometimes produce incorrect answers with a very high degree of confidence. And it would often double down when we would query why those questions or answers were incorrect. So at that point, we had to make a decision. We could invest more time and effort engineering around the problem, or take a step back and evaluate it more broadly. At that time, LLMs were still maturing in areas like maths, So we weighed up the risk, the cost to improve accuracy, and the business value of pushing it to production, and ultimately made the decision to wait. Not because the use case wasn't valuable, but because the timing wasn't right. Fast forward to today, we've revisited that same use case with more capable models, and the results have been significantly stronger. So the takeaway here is that success in production isn't just about whether something works, it's about whether it can be trusted at the level required for your business needs. In production, trust isn't just a nice to have, it's what determines whether the system gets used at all, whether that's from internal users or your external customers. The second pattern that emerges as soon as you introduce real-world complexity, and this is really where a lot of proof of concepts start to fall apart because complexity doesn't increase linearly, it compounds. You have more data, more steps, more rules, and suddenly something that worked well in isolation becomes very difficult to control. This is something I experienced firsthand while building an internal AI solution to automate our sales estimation process. This is something that can take our business days or even more, gathering data across AWS environments, different documentation from customers, applying estimation logic, and producing technical specifications and outputs for our customers. The initial version worked very well for a single AWS account, but as soon as we tried to scale that, multiple AWS accounts, sometimes 5 or 10 or more, add more variability, more rules, the approach started to break down pretty quickly. So we moved away from trying to do everything in one step and instead broke the process down into different stages with clear logic and clear control at each stage. That shift made the solution far more reliable, and today is saving a lot of time for the team while producing technical outputs, specifications grounded in real-world estimation logic. So again, the pattern is consistent. The limitation isn't the AI itself, it's how the system is designed around it. If you take a step back and look at both of these examples, what's happening is not really just a trust issue or a complexity issue. It's that the POC was designed for a controlled environment, not for the conditions it would face in the real world. In a demo, everything's clean. The inputs are predictable, edge cases don't show up, and the system only has to do a few things well. But as you translate this to production, users behave differently than you expect, the data is inconsistent, and the system has to handle far more variation than it was originally designed for. So that third point on the slide, designed for demos, not real-world use, is really the underlying reason behind the other 2 points. Trust breaks because the system isn't robust enough for real-world inputs. Complexity breaks it because it wasn't designed to handle that level of variation. And that's really why so many proof of concepts struggle to make the transition to production. And these challenges, they don't stay contained. They tend to become more pronounced as you scale. At a small scale, things can feel manageable. You're working with limited data, simpler workflows, and controlled inputs. But as we all know, the real world systems are much more complex with multiple steps, retrieving data, processing it, generating outputs, sometimes making decisions. And each one of these steps introduces a small chance of error. Individually, that's fine, but when you combine them, those errors can start to compound. The data also becomes less predictable. You're dealing with different formats, edge cases, and inconsistencies across systems. And you start to see practical constraints emerge. The cost increases, response times slow down, and the operational overhead becomes much more visible. Something that works 90% of the time in a proof of concept can very quickly become unusable at scale. And at that point, you're no longer really evaluating whether the solution works. You're evaluating whether it holds up under real world conditions. and the impact of its inevitable failure to your business. So if those are the challenges, particularly around trust, control, scale, and complexity, what does a system look like when it's designed properly from the start? In our experience, the advancement in AI technologies help, but they don't solve the problem on their own. It's more about how the problem is approached in the first place. In a proof of concept, the AI is usually treated as the solution. You give it an input, expect it to produce the right output, and that can work in a controlled environment. But in production, that way of thinking starts to break down because the AI isn't really the solution. It's just one component in a much larger system. So once you start thinking about it that way, a few things start to change. You stop expecting perfect outputs and instead design with the assumption that the AI will get things wrong from time to time. You stop trying to do everything in one step and break the problem down into different stages, adding reasoning and control at each stage. You stop relying on the model to figure out everything on its own and start grounding it in your own business data, providing rules and constraints at each stage. And you introduce control points along with human validation, which is very important, while managing risk throughout the whole process, not just at the end once you have the final response. So by doing this, the system doesn't necessarily become more intelligent. It just becomes more predictable, which is crucial for its success. And that's what really allows it to work in production because you're no longer relying on the AI to always be right. You're designing a system around it that can handle when it isn't correct. So lastly, before you look at taking something into production, there's a few things worth validating early on, not just whether it works, but whether it works consistently across different scenarios, whether you have the right levels of control in place and clear boundaries around what the system can and can't do. Understanding exactly where human oversight sits, particularly for higher risk decisions, and ultimately what impact it has on your business when things go wrong and how you're going to mitigate that risk. So putting all of this together, the difference between a POC and production system isn't just technical. It comes down to whether you can trust it, control it, and scale it while managing the complexity that comes with real-world use. And that's really what determines whether AI delivers meaningful value or remains something that just works well in a demo. So with that in mind, I'll hand it over to you, Robin, to walk through a real-world example of how this can be done in practice.
No worries. Thank you so much, Jackson, and thank you so much, Daryl, for inviting us. Hi, everyone. My name is Robin. I'm the CEO of Xtramile Solution, the principal, and also acting as the principal consultant. We are a digital health specialist, developing software solutions interoperability around healthcare. Today, I think we're just going to go through some of the examples and our relationship with PolarSeven. Just going to start sharing my screen.
Just nice one. Thanks, Jackson. Just while you're saying that, so Jackson, are you saying that the thing I vibe coded yesterday for 20 minutes, I can't just take it straight to production?
It's exactly what I'm saying.
Good to know. Damn it.
Which is what I tried with the sales estimation tool, but I was out of my depth, so threw it over to a solution architect who had something up and running for us.
Good job.
Maybe 40 minutes.
Yes.
Well, maybe not. All right. Thanks, everyone. Yeah, so today I'm just going trying to give some a little bit of presentations and demo about one of the products that was tasked to Xtramile to develop. So Sister, one of the leading women's health, women's telehealth clinic across Australia that very focus on delivering healthcare services to women across Australia. So just before we actually draw into demo, so I just want to sort of give some idea about what's this AI companion is. So the main objective for this AI companion is to provide some space for patients to be able to express their concern, or being able to look at or discuss the healthcare matter in preserving the anonymity and privacy as well. And the idea of having the AI clinical companion is it's for scalability. Obviously, you know, being able to get patients to get a clinical advice, or even express their concern require clinical support team to be on standby all the time, and that's probably not the situation where Sister can actually service the entire community very well due to the demand that actually keeping on ramping up, and also trying to remove the Dr. Google panic where patients or anyone try to search the condition on Google and start to get some advices that is somewhat out of context with the healthcare situations, and that can create the panic which most of the doctors or healthcare professionals kind of like trying to avoid, for their patients to be on panic mode where things may not be so concerning as they thought, as per the Dr. Google responses. And also dealing with the jargon overload where there are things where all the clinical terms and definitions that the patient may not know about, and they just like, okay, what is this? I don't know what's going on. So all of these things are in mind when we're trying to develop the AI agent, and obviously it can also provide some sort of like extra feature, that the standard easy feature like making a booking, contact support, and those are an easy task. But the main challenge with Sister is to provide clinical guardrails in place. I think Jackson's talk about more about this on his slides, that yeah, it's good to have a 20 minutes POC, but how to make it production ready, in this case that is actually clinically safe, and also within the scope of work that the AI agent can handle. For example, you cannot do diagnosis. You can only provide some advices and direction and that sort of stuff. And for Sister specifically, we because of the nature of the clinic and also the nature of the patient cohort, the agent is to be very compassionate, caring, and understanding, provide non-judgmental responses, just as per what the doctors and the clinical support team in the clinic. So those are the niche, the niche area that is quite it's quite, I would say, quite challenging to achieve to make it production ready, because we need to be able to control the behavior of the agent for every single responses that they make and things like that. And obviously, all of these things can only work if we are able to provide some context around the patient clinical data and the clinical consent together, and providing the good responses while also preserving the previous conversation or history. So that was a challenge that was given to us, and then obviously Xtramile was not the AI expert at the time we embarked this project. So therefore we reach out to PolarSeven, who is the expert on this area, trying to do a proof of concept with us. So since then, so the PolarSeven delivers successfully the proof of concept, and from then on we then take on the proof of concept and productionizing it. Obviously that productionizing it takes several, lots of iterations on refining the guardrails, refining the knowledge base, refining the instructions to the agent to be able to deliver to the outcome that we would like to have. Um, yeah, so that's probably the background to this demonstration. So I'm just gonna go straight to demonstration now. So this is the AI agent, the AI chat that we developed. Obviously, it allows patient to discuss things um, that is very private. That's probably something that do not feel comfortable to discuss this in person with anyone, let alone stranger that they meet. So I think this is the key examples that we put together so that you get some idea about what this is agent is all about. It allowed them to express the clinical concern in the very safe space. um, I know with the telehealth that also provides the ability to do so, but even that there is um, uh, some hindrance or some barriers for patient to access the healthcare services due to the area of the clinical care that they need. Um, as you can see, the response here, it took us a while to be able to provide some responses that are very compassionate and caring and providing non-judgmental responses, and as well as providing a clinical accuracy based on the knowledge that has been curated by the chief medical officer. And that takes back and forth, as Jackson was saying before. Not that 20 minutes POC can be delivered to production. It takes a while to be able to perfect this and make it production ready. Um, throughout the journey, what I can say as well, there are some uh, areas where we think, oh yeah, AI can do all of those things, and what we found that if we leave it AI to do all of those things, it actually detrimental to the customer or patient experience that we have. For example, obviously all of this now, as you can see in the demo, it leads them to book a consultation with the clinical team or the doctor to discuss the matter further, because it's from the agent's perspective, they need to get some help. This is an example where we have a registration screen, and you guys might think, oh, why are you just giving them the link to fill it up? We started the journey by trying to automate everything to an AI agent, get the AI agent to be able to fill all the details, requesting all the clinical info, and all the questionnaire to be filled through the conversation. But throughout the testing process, it took probably patient about 45 seconds or even to a minute, just trying to keep on chatting to the agent, trying to provide the responses back and forth and back and forth and back and forth. What we found out is it's easier for them just to actually pick up the link and fill it up, and they get it done within 10 seconds. So I think this is quite important as well as we develop the AI agent. There are things that we think, well, AI can do more for us, but eventually they're actually detrimental to the experience and performance. Anyway, that's all for me. Probably over back to you, Jackson.
Thank you,
Cool.
Robin.
And maybe just quickly,
Yeah.
Robin, so with the sister app, does all of this get packaged up for the doctor as well to kind of get an overview of what the session might be about, or is that a future consideration?
Oh no, definitely. So once the patient sort of if the end process is booking a consultations, when during the consult the doctor can actually look at the chat history, what has been chatted throughout the initial engagement. So they have a full context on what this is all about. And I think I mentioned also in the slides earlier, all the AI agent also get a contextualized information based on the previous conversation and their medical history as well. So they're well aware their situations and the conditions that brought them into the consult.
Thank you for that, Robin. I think it's the old adage still holds true. You can't. I feel like a lot of people are trying to use AI to fix everything. Whereas you found in your journey that yes, AI was great to go to a certain point, but sometimes it was better to pop out into that link itself. So still the old technology. So it's the hybrid of the two is probably more a valuable solution than just going all in down that AI path. So it's the combination of them adds more value.
That's right.
The just a couple of questions. So we're into the Q&A part now. And we got 5 minutes to go, so I think we're on track with time. I guess to you, Jackson, first. We want to start with agentic AI without taking on too much risk. What do we do? Where do we start?
Yeah, so I guess this one's it may seem quite straightforward, but especially if it's regulated industries, you really want to start in areas where the impact of being wrong is low, but the value of being right is high. So you look for use cases that add a lot of business value, but a much lower risk for incorrect responses. So you design so there's oversight or validation built in rather than full automation from day one, as we kind of see with Robin's example.
Sounds good. And just another question. Do you have a checklist? Do we have a checklist or a key moment to know when the agent is production ready?
Robin, did you want to answer from your perspective? Did you guys create a kind of checklist before launching into production? What was your process there?
Yeah, I think I'm not quite sure that there is that checklist per se in terms of the like standardized checklist, but I think it's going to be contextualized to the case by case basis. So in our examples, there are certain hard rules that we cannot go, otherwise it can be seen as a medical device. For example, providing diagnosis and things like that. So those are the pressure tests that we need to do on the agent to make sure that it doesn't provide diagnosis. On the other side, around accuracy of knowledge bases and things like that. I think that's also another area that is very very what do you call this, precise in terms of testing it to ensure we get a success criteria, that it doesn't go beyond this knowledge base. It doesn't just go to the knowledge that the LLM have. We want to leverage the LLM for the comprehension and thinking, but we want to make sure that all the data input and the responses coming straight from our knowledge base. So those are a very definitive successful outcome. The hardest bit is around the persona, characters, and behaviors. I think that's just testing and testing, refining, and to the point where all the parties are comfortable.
Agreed. It's all about keeping the correct context as well at the end of the day.
Yeah.
Robin, this is another question for you. How did you know that was the solution you needed? Sorry, you're on mute.
Oh, sorry, demand. So basically,
Demand.
yeah. So basically, any digitization project, it's the one of the trigger to digitize is to be able to scale up and meet the demand, right? In this instance, it's just impossible for us to be able to service millions of patients with the same workforce that we're going to have. So in that case, then we need to be able to scale up safely, leveraging technology, and AI agent is obviously the way to do so.
Yes. Thank you for that. And this is probably to both of you, Jackson. Maybe it might be a bit too tech, that's fine too. But thank you for both for your question. But how was the system configured to avoid prompt injection threats and also stay on topic?
Yeah, is that for me?
Yeah.
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 Off you go, Robin.
Yes, yeah. I actually do not know the details, but yes, there is that threat, and then we addressing that through through some other approach that I don't remember on top of my head, because I'm no longer that hands-on. There are some ways to avoid through, I think, yeah, there you go. Thanks Florian. Guardrails and also a few other checkpoints that we get into the AI agent actually screening the actual messages that come across here and there to be able to detect, because we also want to make sure that there is no, because it's in this industry is quite regulated. There are certain bits that we don't want to get. Yes, we can get the health informations come across, but we need to make sure the data is not fully identified. So any PII that come across to the actual LLM, we have to stop it as well. So there are a few things, few techniques around there that that needs to be applied.
And that's great. And we're on time. So just to close out, thank you all for joining. Building a successful AI solution is not solely about technology. It's about establishing a secure, scalable, and governed platform that drives tangible business outcomes. If you would like some assistance with defining your solution, then please reach out. We're all pretty friendly here. You can send us an email. And if you'd like some assistance with defining your solution, yeah, I think there's a QR code that you can scan there to get a meeting. And with that, thank you all for joining, and we look forward to seeing you on the next one. Thank you very much. Take it easy. And thank you, Robin and
All right.
Jackson, by the
Thank
way.
you.
Take it easy. Thank you all.
Thanks all.